Permutations. Okay, so we're going to be looking at something called a permutation with repetition. Okay, and when you think permutation, think position. Okay. All right, so here's an example. Julia, Emma, and Talia have entered a permutation contest where 10 gummy bears are awarded to the first winner, 5 gummy bears are awarded to the second winner. Okay, so 2 names are chosen with replacement. So that means they put the names in a hat, these 3 names in a hat, and they're going to pull out 2 names. Okay, so they pull out one name, they look at it, and that's the first winner. That person gets 10 gummy bears. They put it back. Okay, and so a name will be drawn. That person is given 10 gummy bears. The name is put back into the hat. Another name is chosen, and that person is given 5 gummy bears. Okay. Now the first thing you want to ask yourself, is the order important? Okay, yeah. So it's different, like if you're the first winner than if you're the second winner. So the order matters. Okay, this is a gummy bear, by the way, and this is Emma and Talia and Julia. All right, so the order matters. Okay, so possible winners. So Emma could win first and she could win second, right? Or Emma could win first, then Talia, or Emma, then Julia, right? Or Talia could win first, and then Emma, or Talia could win first, and then Talia again, or Talia, and then Julia, or Julia could win first, then Emma, Julia, then Talia, or Julia, then Julia. Okay, so these are all the possible outcomes. All right, so in the first position, how many possible outcomes are there? Well, there are 3. 3 people could win in the first position, right? So 1, 2, 3. Okay, in the second position, how many people could win? 1, 2, 3. Okay, so it's 3 times 3. Okay, so when we're talking about permutation, order matters. So think, permutation, position is important. Okay, so the order matters for permutation. All right, who is chosen first or second definitely matters. Okay, in this case, we get 3 to the power of 2. And you can always think of it as like the 3 is the number of people. Okay, and the 2 is the number of winners. Okay, or another way of thinking about it is if you put this into a nice formula, like n is the number of objects to choose from, right? And r is the restrictions, the number of restricted choices. Okay, so in this case, we're only picking 2 out of the 3, so r is 2. Well, let's look at another example. Let's look at a larger example. Let's say we're doing the same sort of thing, okay? Emma, Caroline, Talia, Julia, Andrea, and Leslie have entered another permutation contest where 15 gummy bears are awarded to the first, 10 gummy bears are awarded to the second, and 5 gummy bears are awarded to the third. So names are replaced after each draw. Okay, so in this case, is the order important? Yeah, absolutely. So there's a big difference between, coming in first and coming in third, right? Coming in third, you get 5 gummy bears, big deal, but first you get 15. Just saying. Okay, so Emma, Caroline, Talia, Julia, and Andrea, and Leslie. Okay, so we have 6 people here. Okay, so in first place, right, there are 6 possibilities for coming in first. 2, 3, 4, 5, 6. Okay, in second place, there are still 6 possibilities. 1, 2, 3, 4, 5, 6. Okay, like Leslie could get, could be the first place winner and the second place winner. Okay, in third, the third winner could be Emma, Caroline, Talia, Julia, Andrea, or Leslie. Okay, so we're gonna get, in this case, we're gonna get 6. There's 6 possibilities for the first outcome, times 6 possibilities for the second, times 6 for the third. Okay, like that. Okay, which gives us 216. Okay, so permutation, order matters. In this case, we're talking about permutation with repetition. Okay, so who is chosen first or second matters. So in this case, it's going to be 6 to the power of 3. And once again, 6 is the number of people, and 3 is the restriction, the number of winners, right? So it's n to the power of r, where n is the number of objects to choose from, and r is the number of restricted choices.